Okay. So I need to find the window. That's the one. Desktop 5. We need that desktop 5. And it all works. Well, at first, before starting, I wanted to add a few words on that thing. I received it last time, and when I came back home, I have kids. They were like, "Oh, Daddy, now I understand. All this stuff you're doing, it finally all makes sense." So yeah, I'll be pretty happy to get one of these again today, and hopefully one day, who knows, they'll follow my footsteps. Okay, put this here. I must say that I didn't rehearse this stuff very much. I did prepare it well, but didn't rehearse it. So there will be inevitable mumbling at some point. So please be nice. Okay. And with that, let's start. So I'm Artem. I've been a web developer for 12 years, mostly in Rails and mostly in London. Working for a company called Featurist. We are a consultancy doing all kinds of software, mainly web and mobile. About a year ago I moved to Tonon-les-Bains, which is on the French side of the lake. And me and my colleague, who was already there, pretty much, we are now sort of formed official Featurist French arm, and we're looking to connect with the local developers and find some local work. About this talk is about testing, full stack testing in mobile Rails, and it will broadly consist of two parts. Part one will go over how people organize their tests and pains and gains of particular types of tests, and part two will dive into the code to show a few tricks to get more mileage out of Rails system tests. Okay, now first things first, why are we testing? What do you guys think? If you put it in one short sentence, why testing?
Because Janus made us.
That's a good sentence.
To save time.
To save time. Why does it save time? Because it sounds like a lot of effort to you know, there's lots of test code. Why is it the saving?
QA would kill us otherwise.
Sorry?
The QA would kill us otherwise.
Who? QA, right. Well, actually, QA probably welcome the lack of automated tests. Okay, this should really say why automated testing. Fine, I'll save you the effort because I thought about that for about 4 days. And the answer is this. So we need to assert that the expected behavior of the system matches the actual behavior of the system in some kind of automated way, so that it doesn't take long, that assertion. This is of course a complex and ongoing task, and it's not unusual for projects to have 2 or 3 times more test code than the actual production code. So all that code needs to be maintained in order, otherwise it becomes increasingly harder to change, and things slow down, and when things slow down they become more expensive. We don't want that. So how do people organize their tests? The classic approach is the test pyramid. You have probably heard of that. Broadly consists of 3 types of tests. The full stack tests that drive the whole system through the UI. They top up the pyramid. And there's few of these tests. At the bottom lies the vast majority is unit tests. They are, as these brown and green lines indicate, they're fast and they're cheap to write. And in the middle, there's some kind of integration tests between the two. Not the full integration, but some integration is tested in the middle. And how does this translate into Rails? So Rails has system tests, and by the way, I'm talking about the stock Rails here. Nothing fancy at all. So Rails out of the box has system tests that drive the system through the UI. It has integration functional tests. The distinction between two is not fully understood by me yet, but they do kind of test the integration. Well, they can test behavior of controllers, but also integration with the models. So it's a kind of falls into the service layer. And the model tests, they do test business logic in ways. Quickly going over all these types. So system tests cut through the entire stack, UI controllers, models, well, the benefits of that is that we have a realistic test because it really follows the user interactions, and we have an implementation agnostic test as well, because we might choose to, for example, we might choose to reorganize controllers, but our system test is still going to pass because it doesn't really care which controls are involved in this or in this or that. So it's a very good feature of the test. It doesn't really, I mean, it's not going to break if you decide to refactor things, which is good because it's got encouraging refactoring. And finally, it covers all code, by which I mean there is like a unit code, put it this way, like classes and behavior of them. But there's also a lot of code that connects the bits together. And often what happens, especially with unit tests, is that that code is missed out. It's not covered by anything. And of course, system tests, they do exercise the system for real, and therefore, by definition, they cover that too. Now, bad things are, such tests are hard to set up. Well, often to sort of recreate a particular state of your app, you're going to have to recreate, you know, lots of models and with their particular state, and that could be a difficult thing to do and difficult to understand as well when you read such tests. They are slow. Well, they run through the browser, and the browser is separate. Well, first of all, it has a separate application that starts. It's a separate process that runs. Tests and browser talks with each other. All this, of course, is much slower than just running a process in memory. And they are hard to debug. Since they're cutting through many layers, if any of these layers go wrong, then all we in the end have is something missing in the UI, not even an exception in a lot of cases. And so we're going to have to go and find out what's gone wrong, which is opposed to like a unit test where you'd get an exception with a stack trace leading you right at the point of the problem. Next are integration functional tests. Well, since the system tests are so difficult, they tend to only cover like happy paths, and the next layer, the functional test, would be where you'd cover happy paths. What happens when a model is invalid? Is there any flash message? Have we been redirected to the right place, or rendered a particular view, or the errors on the page? Things like that. Right. So yeah, the good things about that easy setup, as opposed to the system tests. There's no UI. You just have a few models really, and then you hit the controller, and there you go, assert. They're reasonably fast because there's no browser. They cover some integration code. Specifically, controllers model code is covered. On the other side, they tie to implementation. Like I said about system tests, you can't just decide to swap controllers and still have these test stars. So you're gonna have to change the test as well, even though the behavior might not change. No UI coverage, obvious flaw. Right, model tests. Business logic rules. Rails advocates for the fat models, so all the actual rules of the system are going to be in the models, or should be in the models. For example, if in the controller test you would test what happens when the model is invalid, In this test, you would test when does model become invalid or valid. They are very easy to set up because you just exercise just one class. They are fast because in a lot of cases you don't even have to go to the database and persist anything. You can just new thing up, and it's totally in memory. It's really fast. They have a good feedback, by which I mean when it fails, there's a stack trace. You probably know what's gone wrong, or just by looking at it. On the other hand, no glue code is covered, so it's test just unit in isolation. You can have as many unit tests as you like and completely broken system. They have a small coverage. Well, that's basically the same point. Well, actually, that was not the same point. Small coverage means they only cover like a specific behavior. So to get some reasonable confidence of overall how overall your system behaving, you'd need a lot of these tests. But so in comparison with model tests and controller tests, system tests might aren't exactly winning. I don't think. However, they have one crucial difference. They do cover your user interface. And when we don't cover user interface, what tends to happen is, no, not this. How do I actually click on that thing? Oh yeah, what tends to happen is this. It's just a minor UI change. Wow, it's a beautiful video. But the metaphor is there. It's a very long video as well.
Is it wood? Is it
It
wood?
does sound like wood. Well, hopefully that convinced you that it's important to to have some coverage of your user interface. Well, if not, it was a funny video, I think. So, back to the system test. Looks like we need some. Going over the the test pyramid advises us to have few system tests. But that's only because they are hard. They're hard to work with. Otherwise, if they were easy to work with, we should just have only them and that's it. But that's unfortunately not the reality. But the reality is that they're constrained by these bad things about them. But if we were to reduce the number of these bad things, then we could have more system tests and still have a balanced test portfolio. And the one thing we're going to take on is slow. We're going to make sure our system tests are faster. And if we can do that, that means that we can have more system tests, and we can have, if we can have more system tests, that means that we have the amount of useful tests, like super useful tests, is going to be bigger, and that's good. Before we get on to how we're going to do that, I'd like to have a word on why test speed is one of these poopy things. Why is it important? Why slow test is bad and fast test is good? It is more important than it seems. In words of Gary Bernhardt, who is a prominent figure in software world, he says, at 40 seconds, you can't do the thing that I call TDD. It just doesn't exist anymore. At 400 milliseconds, of course you can. To paraphrase, what he means by that is that when you're programming in the flow, you can't have anything that takes 40 seconds. That breaks the flow entirely. You can either have flow or you have 40 second things. So as soon as the things get slow, any of them, any step in your workflow, then that's that. And flow is good. Flow is something we want to achieve. We want to keep the flow, because that's very productive. Let's have a look at what Google has to say on task speed versus user focus correlation. That's not specifically about tests, but it is about the generic user interactions with any system. So they have this fancy table here that's broken down by particular time frames. The interesting ones for us are down the bottom. This one. It says that beyond 1 second, the user loses focus on the task they're performing. And beyond 10 seconds, users are frustrated and are likely to abandon tasks. They may or may not come back to it later. Well, probably when you talk about tests, we're going to have to come back to it later. But this is universal. This follows the test speed developer focus is exactly the same thing. As soon as something takes sufficiently long, you're likely to wander off to Hacker News or Twitter or what have you, and that's your flow gone. So certainly we don't want that. But most importantly, slow things are annoying, and we don't want to be doing annoying things. In fact, we want to be doing less annoying things. And for that reason, when tests become slow, you tend to run them less often. And of course, when you tend to run them less often, what happens is that you tend to put a lot more code in between the test runs. And what that means is that next time you run the test and something fails, it becomes harder for you to understand what's gone wrong, because you can't hold that much code in your or it's harder to understand what triggered the failure if the change was big. If the change was one line, you may be able to just guess it. If the change was 100 lines, unlikely. You're going to have to go down to logs and stack traces and try to figure that out. So inevitably, slow tests end up be running exclusively by CI and not locally, and that's just even exacerbates the problem because it takes even longer. Right, so speeding up Rails tests, what are we going to do about that? And we're now approaching the second part of the talk, the practical part with the code, the fun bit. So we're going to use, and I'm talking about stock Rails here. So stock Rails come with system tests that's driven by Capybara using the real browser, Chrome, heading. So the first thing we're going to do, we're going to make sure we can run our tests in headless mode. Second thing we're going to do is that we're going to make sure we can run our tests through the real browser and through a thing called Reqtest. How many of you know what Reqtest? Okay. So Reqtest is so what about Capybara? Capybara is a library that ships with Rails that allows you to navigate the browser and assert that things are in the DOM. Basically, it's your tool for testing through the UI. Capybara is an interface. It has many drivers behind it. One of those drivers is Selenium that starts Chrome or Firefox and navigates to your website, your test website, and clicks the links and fills in the forms and all that stuff, asserts things in there. But that's not the only driver that there is. Capybara also ships with a driver called Reqtest that doesn't run through the actual browser. But what it does, it plugs in straight to the controllers, analyzes the HTML that they spit out, and based on that navigate your website and assert things are there. Well, of course, the downside here is it doesn't run in JavaScript, but we'll get back to that bit later. So third thing, we're going to switch to Reqtest. Some tests really don't make any sense without JavaScript. Some functionality, for example, integrating with Stripe, for example. It's very hard to express in non-JavaScript world. So we can make sure we can easily skip certain things and run only in JavaScript. And finally, the most cool bit is when we're going to make our demo application, our prepared demo application. We're going to make it work in both JavaScript and non-JavaScript environment seamlessly. Okay, so switching to the code. Yeah, but how do I do that now? Going to the different screen. That was a screen number what? Number 1? Number 5? Can't remember. There you go. So that's screen number 5. So let's move that to number 5. And switch to here. The application I've got is a very simplistic Rails app, Rails 6 application. I'm going to revert to the commit where it's just that I had none of these, that I've done none of these changes yet. That's the one. Okay, so, and I'm going to run system tests. By the way, I'm only focusing on system tests here, nothing else. And we're going to observe, hopefully in that window, yes, we observe like it starts 3 Chrome windows, we'll load up the app and do its thing, all passing. And so the first thing on our list was to make sure we can use headless code. Because it's going to be slightly faster, but also it will be a lot less annoying because that thing just flickers on my screen. I don't like that. Okay, so we can do git rebase continue on to the next commit. And actually, what I didn't show you, I was supposed to. Application, no. System, that's the one. So I didn't show you how it looked before. Let me do that again now. So abort, and now we do that again. Right. So this is how it looks out of like Rails new. This is your system taste-based class. It says driven by Selenium, and that's what we saw. So we saw some Selenium Windows, Chrome Windows popping up. So we're going to make sure we can use seamlessly. We can use headless Chrome. So continue on to the next commit. Now this is how we register another driver in Capybara. It is a headless driver, and based on environment variable, we should be able to still go back to the header mode. Otherwise, this is going to look like this now. As you can see, no browser is there, and it's also slightly faster. Let's actually put it to test how fast. And if we do, so that was 4 seconds of new time. Give me 1. Let's test system. Right, so that's almost 2 seconds more. That's already a step in the right direction, but we can do better. So the next thing will be to make sure to, oh, we have my code coming. So I have
a question.
Yeah, go.
Does all this advice apply to the different versions of Rails? So 5, 6, or
5 definitely yes. Well, I'm not sure, but well, to some degree yes, to some degree. I wouldn't. You'd have to look into the like Rails system test didn't exist until before 5. think, or 5.1.
Local feature tests.
Oh yeah, so I mean, not sure about that.
More or less, yeah.
Right, yeah, so we can do much better. We can now switch the driver to run same tests in without any browser. So let's continue again on the next commit. And now if we look here, we have slightly more code, and we're now swapping the driver based on presence of these two line variables. We're either going to be running Selenium or Reqtest, and see how that looks now. Right, so that was 2 seconds. That's like twice as fast as JavaScript. So that's good. Of course, the I'd like to rewind a little bit and show you a capybara test, just so people who are less familiar with it understand what it actually is. So all those things: visit, click on, fill in, click on, insert text. This is the API that capybara provides, and no matter which driver we're using, it's guaranteed to work in the same way. Which is why we can test. We can run the same test through the real browser or through the just HTML piped out controllers, and make these and so we can test the behavior of our system without running the expensive browser process. Of course, some features, like I already mentioned, they don't make any sense in non-JavaScript world, and with that helper that we've got here, excluding those things from test runs would be as easy as this. So if we want to exclude some things from Reqtest, well, we can do that very easily. So finally, the last bit on our list was to make sure our app can behave in both JavaScript and non-JavaScript world. So at this point, I'd like to show you what is actually the app I'm talking about here. So this is going to be here. No, not here. Sorry, that's actually work. Let me fix that and start the server here. Okay, so I build a little Hacker News clone this way, where you can create posts and then comment on my posts, comments, and then you can reply to those comments as well. So at the moment, as you can see, the site is non-JavaScript, even though it runs TurboLinks, so all the links are JavaScript defined. The actual submitting forms and stuff, that all happens in non-JavaScript world, just like the Hacker News itself. Funny enough, it doesn't have any JavaScript whatsoever on that website, and still it rules the world. So as you can see, when we reply, when we reply on the comment here on the Hacker News, it's a very long comment. We're on a new page. When we submit that page, we're going to go back to the parent thread, which is exactly the behavior we've got here. And now we want to change that model into Reddit style model. And the Reddit style model is single page application. So when we click reply to a comment, the form is going to appear here, and when we submit that form, no page load is there. It's just the rendered comment appears on the page. So we're not going to do that in real time, but I'm just going to continue again, and we're going to magically have that working that way. So if we go here, we shall see post a new comment, it just appears instantaneously, and if we reply to it, same thing again. Okay. Right. So, and this is an SPA, by the way, single page application, no page loads, but it's done in such a way that it falls back to the non-JavaScript version seamlessly, and it uses only stock Rails APIs and stock Rails tools to achieve that. Namely, what it is using, it's all the links have a remote to true option, so they became Ajax links. All the forms, all the form width have option local true removed, so they again behave like Ajax links. And we do make use of the content negotiation block respond to format. So we have two versions for HTML and for the JavaScript. So let's look at what happens when we do reply, when we press reply button. When we press reply button, request goes on the server and it comes back with some JavaScript. If we were to disable JavaScript, what is it? Yeah, disable JavaScript. So the same thing is just going to go to the non-JavaScript version of the website. So it behaves the same way. Page again. Right, so reply comes back with some JavaScript, as we've seen. How does that work? Where is that? Why can't I? Anyway, doesn't matter. I'll show you the code. So this is our request for the link, like the same link too, and for the this is the link that's on the reply link. So it comes to the comments controller, and the comments controller and to the action new. Let's look at the controller. Here, the action new is right there. It's very simple. It has this respond to block. What that does is that it's going to render new template, but based on the format of the request, it's going to either render new.js or it's going to render new.html. And new ones is going to be these two. So the new HTML looks very familiar to everyone. So it just has a h1 and then it renders the form. And the new.js looks slightly bigger, but crucially, it also renders the same form. So we do that JavaScript. It doesn't create any DOM. So all the rendering happens at the same, at the same place in Ruby. So that code is reused. The JavaScript that we see here only defines where do we insert that render DOM, because in single page application you kind of need to know where the blob of HTML needs to be inserted. So this is the part that inserts it, and this is the part that also removes it if we want to remove it. So and the link, just to be, was it comment? The comment link, the reply link, is again just a regular old Rails link. There's just one extra option. The interesting bit about the extra option is that if we happen to be in no JavaScript, it's just ignored. It becomes a regular link that behaves like an HTML link. So that was part one. Part two is submitting forms. So what happens when we submit forms? Like I really need to start being able to resize that thing. Anyway. Okay. Right. So again, very similar thing happens. Just some JavaScript comes back, and that gets evaluated by Rails UJS. But what happens on the server when we submit that form? Actually, the form is going to be, this is the form. When this form, again, regular Rails form, nothing fancy about that. It just submits to the comments controller. It behaves exactly the same way in JavaScript or non-JavaScript level. And here is our post. Again, Rails recognizes that we are in JS environment, so it's going to go and render. It's going to call that create action on the comments controller with the format JS. See the comments controller here. Create action is this, and exactly the same thing as we used here. We're going to use here. So if the comment is saved successfully, we're going to either do the non-JS thing, which is redirect back to the post, or we're going to render that create.js template, which is here. And again, this is just once again the actual DOM that's going to end up in the browser is rendered by Rails. So there's no duplicate rendering. Like there's no two ways of render the same thing here, which I think is very important. The only thing is going on here is, again, we just need to work out where exactly to insert that thing, and based on if it's a post comment or it's a reply to a comment, we're going to do slightly different. And this is what we see here. It's only one part of that if actually shows up. Just so you don't take my word for it, let's run those tests. Let's test system. So this is by default now runs without any JavaScript, and it passes. And we're going to run the same tests in JavaScript. In reality, in real projects, I mean, it's surprisingly nearly faster than the other one, but no, it's not. And when I'm working on features, when I'm writing tests, locally, I only run these version tests because it keeps me reasonably fast. Of course, when something doesn't work, then you can't really debug the Reqtest. It's hard to debug that one. So what I do, I just switch to the GUI version, to the browser version, and debug it there. But if I want to run all my tests before committing, for example, I would just run a Reqtest exclusively, and then on CI, CI just runs them all. So it runs Reqtest, and then it runs the same tests in JavaScript. So this way, we don't really compromise on how real our coverage is, because face it, Reqtest is not the real browser, and it doesn't run JavaScript. And our application, this application is a single-page application, so we still need to run those tests in JavaScript. However, we could offload that to CI, and most of the functional errors are going to be caught by these fast versions anyway. And that's, I think, let me check my slides, but I think that's about it. Right, to recap, headless Chrome, very simple change, Reqtest, slightly more complicated change, especially if you're an existing project that already has, it is already heavy on the JavaScript, might not be even possible. But on the new project, before diving into things like React, perhaps, you really should ask yourself, do we need all that JavaScript everywhere, or maybe we could just use turbulence and sprinkle some JavaScripts here and there where it's absolutely needed, because that's a big this is a big argument for not having a lot of JavaScript. Amongst other good arguments of not having a lot of JavaScript, this is also one of them. Yeah, well, of course, there's always odd one out, 2 or 10, and it's straightforward to exclude those from Reqtest. And finally, if you feel like doing something cool, then you can try that thing. And that's it. Maybe you have any questions?
Are there any downsides to working this way? Have you found pain points to working like this?
Well, yes, certainly. So when you go down to, when you go too much down to the part of I'd like my system definitely working in both ways, and you have complex JavaScript UI, then it becomes quite a task to make sure your system works in both ways. Again, you don't have to do that. This is a choice that you may just decide not to do and completely exclude certain subsets of your test from JavaScript. But it is, I know that the line is blurred. I personally fancy taking it to the definitely everything is covered in Reqtest, even stripe tests. So yeah, that would be one downside. But that's only about the very extreme, I'd say, option, which is I'm going to make 100% everything run in both ways. Which is basically making run one thing in 2 modes is harder, because otherwise it's just twice as hard, not twice actually, as I've seen Rails supports these kind of fallbacks pretty well out of the box, but it is still hard.
I have a question. It's not quite related to the tests, but more to the implementation you showed us. My question is the following. I'm sorry if this sounds a bit silly. I'm not a front-end guy since the jQuery times. The question is the following. This approach of sending the JavaScript to the front end to be inserted and executed, is it something general, or it's just your Ruby related thing, or it's used broader?
I don't think it's a very popular approach these days, but Rails, and Rails is a big name in the web development, has supported and still is supported these kind of workflow out of the box. So I would say it is a pretty standard thing to do, even though people don't use it very much. That doesn't sound very right, but
I know with Stimulus it's like the default way.
well, I mean, I haven't used Stimulus, but maybe that.
Yeah, Stimulus is the new Rails JS framework, and it's doing exactly that. And the big advantage of Stimulus is that you don't duplicate your views. You recycle, in fact, your server side rendered views, and just send back the.
Right. Well, so maybe that maps well onto the Stimulus framework.
Yeah, exactly. That would work with Stimulus as well. I mean.
Well, yeah, Stimulus is an evolution of this. This was used a lot before Stimulus. I mean, it's still doing this type of thing.
Yeah.
But yeah, so you share the partials, right? So you might render the partial just with the regular Rails page and share it with some other code, and then you can render that same partial as you explained, and you can push that down, and you can wrap that a bit with some JavaScript, and then add it to a certain place on the DOM.
Gotcha.
Yeah.
Okay, so that would take care of that JavaScript that I used to find where to insert.
Oh, I mean, what you demonstrated is perfectly fine and was used for. In
fact, I still use it. So. But a stimulus is kind of trying to organise JavaScript a bit
Right.
better.
Yeah. Okay. Sorry, 'cause I see what you're saying. So what organizes, that bit where we need to find
Exactly.
where we insert, how we
Exactly, yeah.
prepend. I see. Right.
It also has the advantage of, not to divert too much, but you can look at the template and you can see in the template where the JavaScript's connecting,
Mm-hmm.
right? Because Stimulus has controls which are just HTML
Right.
elements.
Okay.
Yeah.
Okay. Well, that's interesting. Definitely, I should probably tweak this.
Another question. Do I understand it correctly that all these code snippets of JavaScript are stored in the database as templates that are being kind of prepared on the back end and send it over?
No. None of this is stored in the database. This is a source code this is a code. The only thing that's stored in the database is actual data, like a comment in this instance,
Okay.
or parent post. So
it's hard coded, kind of.
Well, in this template, see how there's ERB, which is the bracket with the percentage. So that part is
this bit.
process exactly there, and even the if and the else.
Yeah.
So that's processed on the server.
Okay, similar to JSP and.
That.
Exactly, yes, just like that, and then the whole thing is pushed down and then executed by.
Like
the
if you
browser.
see, this should resemble. So this is the final product of that of evaluating this. So this is a rendered HTML for a comment, and this is what we see here. This bit.
Yeah.
And this is just one branch of that if. See that if here? So if it's a top level comment,
Okay, so
one thing.
Like a servlet output, but with a lot of JavaScript and where you can put JavaScript and execute it.
Yeah. So it will be evaluated by the browser.
A comment I had about system tests, it was not one of the downside you were showing. That they are still quite depending on the UI, and it's a good thing because it's testing the UI, but at the same time it's depending on the UI. And especially in the beginning of a project, your UI changes a lot usually.
Yeah.
So you build those tests, and you're constantly refactoring.
But when you say depending on UI, you mean depending on the HTML and classes. So what we've been doing on some projects, and I think this deserves some thought, is, let me show, this is a real project, let me show you some steps somewhere. So there you go. Right, so we have been using that what's it called? I forgot already, that metadata that you sprinkle into.
It's attributes.
How's it called?
Attribute?
And it's called
Data elements.
not even data elements.
ARIA.
No, not that. Come on, keep looking. It's
The micro format.
microdata. Is that what it's
Micro
called?
format.
Micro something. Microdata. Oh,
Microformat.
I always forget. Anyway, so that would just so this test here, it doesn't rely on any HTML, doesn't rely on any CSS. So it relies on some metadata that you put in your HTML, and that means that you can change the structure of your HTML without breaking the test.
But
so
still you have to replicate those. So if you change the DOM, you have to think about this product name format you have to move and do it, and
but if you change the class name onto some other class name, now you won't get failures, right? So at least your CSS classes, they're now specifically about the visual thing. They no longer will affect.
I think it's a good trick to divide. But for example, if your UI, your design is coming from a designer, then it's your problem then to.
Yeah, you're gonna have to. There's no two ways about that. You're gonna have to insert these things in the right places. But I think it still it makes it easier.
This represents the data of
Yeah.
the page as opposed to the style or the layout.
Yeah.
That's the idea.
I mean, yeah, that's one of the difficulties with what happened in the front end, right? Like CSS classes are supposed to be for styling, but then they get used to JavaScript grabs them, and then we use them in tests as well, and of course the whole thing becomes complicated.
Well, there's a naming convention where all your JavaScript handles have a JS at the end, so that your style can be, your CSS handles can be different than your JavaScript handles.
Okay, yeah, sure.
Yeah. Okay. Do you have any other questions?
That's interesting, because we totally had this kind of problem, like having very slow tests, especially the system test. And that's one of the first things that Ben or Neil did first. It was to move to headless Chrome. But we haven't tried the Reqtest. The problem for us is JavaScript is everywhere.
So it probably is
on an existing project. It might be tricky
to the downside of this approach. It's probably difficult to retrofit.
Also the JavaScript, the server-side rendered JavaScript works until a certain point in terms of UI, but as soon as you are very complex or quite complex, then you are a bit in terms of organization of the code and moving to something like React and having a proper API single page app makes things much easier somehow. And then
of course you can't.
But also another problem with a lot of JavaScript-based tests is it can just fail, and then you run it again and it passes, right? This can happen. I don't know. I mean, if you have hundreds or many tests, sometimes, particularly on CI, flaky tests, exactly. It'll fail, and then you just rerun it and then it runs, right? And the solution for that can be allow this step to fail, which is.
We have another solution for us. It's just to repeat the test.
We all do that. I mean, interesting about the Reqtest idea is that if you've got the Reqtest passing but the other one's failing, then it kind of narrows the surface area for where things went wrong. In theory, in practice, of course, that might mean that you just didn't quite right, quite behave the same way. But at least in theory. Flaky tests. Tim, my colleague Tim, who's here, you can tell a great deal about flaky tests. And I think in the end they all boil down to the actual problems and bugs in the UI. However, very often those are just not bugs and problems not worth pursuing, because it's just because tests happen very fast, and some race only happens when the computer clicks things, but never going to happen when the humans do that. But I think we have found more often than not, definitely, that if you just really start looking into it, and it often uncovers problems. And it's hard to debug, it's hard to get down to it. You can spend days. If you've got days, you can spend days. But it's very often actually leads to some kind of a revelation. It's not a magic box at the end of the day.
So just by curiosity, at Featurist, you have a project that you're maintaining for now, months, years, that have grown and changed, or usually you have client work and you just build something for what kind of things are you? Just client works you build for a few weeks or months and send to the client, don't touch it never, where this kind of strategy might be the best somehow. Because I can see that for a project which is growing quite organically, with the agile way of building stuff, those feature tests and system tests are very difficult for us to maintain. So I don't know, The metadata stuff could work, but what kind of work are you doing at Featurist? Like this small application that you send us?
There's probably, we do little jobs, in which case often it's not, it doesn't really pay to do a lot of testing, because it might take you an afternoon to, if you come back to it in 6 months' time, you get your head around it in a few hours, and you can test it manually pretty quickly, and you probably don't need a whole lot of automated tests there. But for other kinds of work we do, we've just finished a job with a client, and we were there for 3 years, and we had something like 4,000 automated tests, and about 1,000 of those were UI tests.
Okay.
And so, and that project was so complicated, and the requirements so complicated, that I don't think anyone would have finished it without having that safety of having the tests and being able to run the tests.
So what was the proportion of system tests in this?
It wasn't Rails, first of all. We did have nonetheless a similar setup of, it was a node project, so there we could use this electron magic that I mentioned before. But we did have a lot of
it was pretty heavy on the end-to-end tests, wasn't it? And the end-to-end tests are good for, you have a realistic scenario of what's happening. But there's I think Artem pointed out, that it does come with sort of the burden on setup is high. You have to spend a lot of time setting up the environment, and the data is complex, and then you invariably get if something goes wrong, it could be anywhere in that system that something went wrong, as opposed to say unit tests, where it's pretty clear what fails, somewhere in that unit.
I guess to answer your question, most of our work is long run projects.
Okay.
Occasionally there would be a small thing, but
And
with the Rails, actually, our oldest Rails project is only like 4-5 months old, so we haven't before it was mainly Node. It just happens right now with Rails, so we haven't reached that point of like a fast Rails code base where that wouldn't scale. Like right now, both of our projects, they run Reqtests and Javascript tests, so perfectly fine. But I guess that's also because we have this we don't want to let a lot of JavaScript just because like that thing is useful, we like it, and therefore we're quite conservative on when it's needed. And of course there will be JavaScript, but if it's not necessarily should be there, then it's probably not going to be there. So I think that gives us a concrete reason to resist the complexity that comes with a lot of JavaScript, a lot of clients, especially in Rails, where you have two completely separate environments, like JavaScript, different languages, everything, tooling, everything's different. So I think it doesn't really help when you have, well, when you can't get away from it, then of course you have to. But if you could get away with it, it's good to consider not getting into it. I think a lot of there's a lot of mindset of like welcoming JavaScript just because it's fancy or cool.
I mean, maybe to be clear, we just did this Node project, and everything was JavaScript. I think the priority was to make sure things were testable, and not just invite new bits of technology that would make things difficult to test. And in the Rails case, a lot of JavaScript makes it slightly more difficult to test, and you're having to use Selenium, which is just slower, etc. And if you're using, we had a big the tension for us with this Node project was to have lots of sort of microservices and API gateway logic, which is outside the project, and we were thinking how on earth we could test that and be sure that when we deploy it all works. So there's always this sort of tension of like, do we add this technology and what sort of costs is that going to incur in terms of test performance or verifiability? Or, something to think about.
Yeah, puts it all into a perspective, right? If you just, set these important things, right? Test speed is important. Then everything is, it puts every decisions, or a lot of them into some perspective. Like, okay, React, everybody's using React. It's actually a cool thing. And if you don't have any perspectives on it, you might think, well, everyone's doing it, so that must be a good thing. But if you have like these guidelines there, like, okay, how is it going to affect that thing? Not good. It's going to slow it down. Therefore, I'm going to become critical towards the idea. And only accept it if it really, if it's beneficial in some other ways, and the benefits that outweigh the cost.
I think that's a very good position to start from. How can we keep our tests fast, right? Because when we write code and we write tests, we refactor our code and we come back to our code, but our tests, we usually only, myself, they're a secondary thought, right? You come back to them because you've changed some code, right? You don't necessarily go and refactor tests just by themselves, right? But in fact, there'd be a lot of benefit in doing that, right? Because maybe you're doing redundant testing, maybe the test path is too slow or whatever, but to treat tests as actual code and really consider them as that type of asset, I think, again, it's more work, right? And it's more development time and everything, but on these large projects, it pays off, right? Because you do the Rails upgrade and it runs, or it fails and you know why it's failing. And
it's a difficult thing to upsell, however.
Absolutely, yeah. Or even refactoring's hard to upsell, right?
Yeah.
So,
well, usually you should not. I mean, should be part of the.
Right.
Usually you do it silently and you don't even speak about it. No?
Well, I mean, there's always sort of on the project you have managers that asking you what you're doing or what you've done yesterday, and then if you keep mumbling 3 days in a row, then you find a test and they start.
I've been working really hard
funny
for 3 days.
Yeah.
You'll see no change in the UI.
But I absolutely agree with that. But it's hard.
A quick question, a bit naive and a bit out of the scope, but when Rails came out, test unit was built in already, no? I think it was in the Rails version 1. It was really a bit a change of mindset also to have.
The testing, yeah.
Yeah, testing really built in. And how much do you think it has changed the landscape of web development somehow? With nodes now, you also have solutions to not really built in, but to test, and other frameworks have adopted this, or you as a developer having done some Rails development before and now changing and going to Node, suddenly you maybe don't have those those tools at hand, and you look for the solution. And have you felt this need of having like strong test suites in other kind of projects?
Like that there's not enough tooling compared to Rails, is that more?
Yes and no, but when you have done some Rails development for some time and you move to something else, suddenly you say, I don't have tests, I'm a bit lost. you need this this how do you say that?
It's a philosophy, right?
Yeah, it's a philosophy, and
tests were always part of a really strong part of Rails.
I think they just really had it.
Yeah.
This whole movement in web development. But I mean, I only worked on so many projects, so I do notice that, especially in React world, it's like things like full stack testing is not. I mean, the full stack and React developers, they sort of, those that I've seen, especially young ones, I think nobody thinks full stack. They tend to think like the front end just ends at the API,
sure, and
someone else is taking care of the rest, and someone else is then putting it all together and make sure it works. But it's only anecdotal evidence, so think that React JavaScript front-end developers, well, they even call themselves, but it's even called front-end. Obviously, that already cuts it off in half. So it's no.
But is that also to do with like the front end has become so? I mean, if you're using all these tools, right, it's become so complex that if you really want to be, really great, you have to just basically focus on that. Right?
Yeah, true. True. I mean, this is personally, this is a bit of a downside of React. It didn't have to be that difficult, but it's a topic for another day.
Yeah, we should go for pizza.
Yeah.
Yes, thank you very much, Artem.
Okay.